Hey folks, welcome back to LLM Fundamentals. In this video, we are going to understand what is a large language model. We are also going to understand the mathematical intuition behind the large language models. So let's try to understand LLM with this analogy. So consider a scholar who has read every book, article and web page ever written on the internet. Now, the scholar didn't memorize the words, they absorbed the pattern of the language, knowledge, and reasoning. Now, once that scholar is well versed with entire knowledge, and if anybody come to that particular scholar and ask a question, any kind of question which is available in this web page or any book or article, the scholar composes a fluent answer and gives the answer very fluently. This is what the analogy of large language model. On a very similar basis, large language model also works. So in a nutshell, you can say a large language model is an advanced type of artificial intelligence that is trained on huge amounts of text data to understand, generate and predict human language. If you remember, in our ML fundamentals, Harish has already explained you what is a model and how we train a machine learning model. So LLMs are also nothing but a machine learning model, but since we take a very huge amount of data in order to train this kind of mathematical models, that's why these models are called as large language models. And once that training happens, they are able to confidently give us answer very similar to this analogy. Alright, so we have seen the bookish definition of LLM and we have also understood this analogy. Now let's understand how we can represent LLMs mathematically. Mathematically, we can say LLMs are nothing but just a probability engine which take a lot of sequences in its input and try to predict the next best possible word for us. The same thing can also be represented in an equation format like this: probability of getting the next word given all the previous words. So in a nutshell, what LLM tried to do, it tried to predict the most probable next word for us given all the previous words. Now, if you have used ChatGPT or Gemini, you may argue that whenever we go to this platform and ask any kind of question, we get all the answer in one go. We have never seen that one word is getting predicted at given point of time. But trust me, behind the scene, all of these models, be it ChatGPT or Gemini, they only predict the next word at given point of time. Now how they do, that's our entire journey which we will be covering in the LLM fundamentals. But for now, you just take my words that LLMs are just nothing but they are doing the prediction of most probable next word given all the previous words. Alternatively, you can also express LLMs with the help of this equation, like y next equals to function of x1 x2 x3 xn, where x1 x2 x3 xn are nothing but different parameters in the LLMs and y next is nothing but your next word prediction. Now what are these parameters? We have to understand it thoroughly, so we will be going deep in a moment in order to understand what are these parameters. So in order to understand LLMs in a mathematical perspective, we are gonna consider one example. So suppose we want to predict a student's marks based on hours studied, and for example we have this data, so where students are learning for 1 hour, 2 hour and 3 hour, and these are their corresponding marks in any kind of test. So let's suppose we want to create a model or a machine learning model which can do this kind of prediction. And if you remember in our machine learning fundamentals part, where Harish has already explained you a movie recommender system where we were trying to predict a similar kind of movie whenever a new user will sign up. Here our goal is little different. What we want to predict is, for example, if new data points will come, let's say, instead of 1 to 3 hours, if a student will study for 5 hours, then what is his corresponding marks? So that's the goal we want to predict. Now, in order to solve this particular problem with the help of machine learning, we can use something called as a equation of line. So you see the equation of line is y equal to mx plus c. Now here let's try to map this particular example with the help of equation of line. So y means over here we want to predict the final answer, or you can say marks. So in our case this marks variable will become y, and x is the input, which is basically number of hours the student are doing the study. So that is become the input for the model. Now what is m and c in this equation? So m is how fast marks is increasing and c is the starting value, and these two things are also called as parameters for this equation y equal to mx plus c. Now this equation has a very specific name when it comes to machine learning, and it is called as simple linear regression. So from now we will call this equation as a simple linear regression, where y is the marks, x is the input, that means our number of hours studied, and m and c are parameters for this equation. Now if we are going to create a machine learning model which will predict, for example, if x is 4 hours, in that case what should be the marks the student should be getting in their test. So in order to get this prediction, we require two parameters m and c, which needs to be calculated, and that is what simple linear regression do. It basically try to find out this m and c, or you can say optimal value of m and c, and with the help of that we just need to put that m and c value in the equation, and input will be coming from the user, that okay, if number of hours of study is 4, in that case what is going to be the marks. So once we have the m and c value available with us, we will be easily able to predict the value of y, which is nothing but marks. Now let's try to visualize how we can able to calculate this m and c with the help of this particular algorithm, which is called as simple linear regression. So you see, I have created this visualization where first of all I have taken my all of the actual data. So this pink dots you can see, so these are my actual data points, and we have only 3 data points, right? 1, 2, 3, and for corresponding marks is 10, 20, 30. So if you come over here, you see on the x-axis I have drawn, like, taken the hour studies, and on the y-axis I have taken the marks, and I have tried to plot these data points. So this is my first data point. For 1 studied hour, marks is 10, for 2 hour of study, marks is 20, and for 3 the marks is 30. So these are my actual data points I have just plotted over here. Now if you see this particular data points, and when you try to connect all of these data points, so you will see this particular dotted line which is going through the origin, which is 0, and it is going into the straight line, and this line is also called as best fit line, and the equation for this line is going to be y equals to mx plus c. Now what is m and c over here? So c is generally your y intercept, right? So you see it is already going from the origin, so in this case c will become 0, and m value, you see we have come up with m value as 10 over here for this best fit line. Now the algorithm needs to find the value of m and c, but if you are just consider this line, in this case we will be able to find, okay, m equals to 10, right? So that's our equation of line. We have this passing through the origin, so the equation of line will become y equals to 10x plus 0. So that's the equation which is for the best fit line over here. Okay, so once we will get this best fit line, we will be able to predict for any number of hour of studied what should be the marks. For example, if the number of hour of studied is 2.5, so we just have to take this point and project to this line, and corresponding y-axis where we will have the marks, it's somewhere going to be around 25 marks. Let's suppose if we consider a 3.5 hour of studied, in that case you just take this point, project to this line, and the corresponding value is going to be somewhere around 35 marks. So in this way we will be able to predict the any kind of number of hours studied, for that what is going to be the corresponding marks for that student, right? So this is how, once we will have the best fit line, the model try to predict the value. Now the question is, once this algorithm starts, it doesn't have the m and c value, or you can say it doesn't have the optimal value of m and c, and that's what the job of this algorithm. It try to find it out the m and c value automatically, the optimal value. And when algorithm starts, so we initially define the m and c value randomly. So we take any random value of m and c. For example, we have chosen the m value over here 0, you see, and we have also chosen the intercept value as 0. So c and m value both are 0, and from here algorithm starts. So with this m and c as 0, the equation of line will become y equal to m into 0 into x plus 0, which is going to be y equals to 0. So basically the line will is nothing but it's a x axis only. So you see we have this particular line, y equals to 0 is nothing but a equation of x axis. So you see we have this purple line, which is our first line with the value mc as 0. Now when you try to predict the your marks for 1 hour of study, you will get the 0. Even for 2 hours it is going to be 0. Even for 3 it is going to be 0. You take any value, you will get the predicted value as 0. So that is the first step. Now model tried to first start with any m and c value, and then it tried to adjust the m and c value in such a way that it should be able to reach to this best fit line. So we started with m and c as 0 0, and we got our first line in this way. Now after that model will try to find it out the error. And what is the error? So error is basically difference between actual value and the predicted value. So let me show you one more chart. So you see we have multiple value of m over here and multiple value of c over here, and let's consider this point where we are starting m as 0 and c value as 0. All right, now for m and c value of 0, we will get our prediction y equals to mx plus c. So this is the equation, and this is also called as forward pass. Now once we have the prediction available to us, what we will do, we'll try to find it out the loss, or this is also called as error. Now the formula to find it out the loss or error is the actual value minus predicted value, the whole square and summation of all the data points divided by the number of data points. In our case it's 3. Now as an applied AI engineer, we really don't have to remember this formula, just the concept is fine. We call this entire thing as a forward pass, where we try to find it out the prediction and we try to find it out the loss. Now once we have this loss and once we have the y prediction, now the thing is we need to adjust the m and c value, and in order to adjust the m and c value, that is called as updation state, and that happens with the help of one another algorithm, and that algorithm is called as back propagation algorithm. Okay, so with the help of back propagation algorithm, we try to update the value of m and c, and the formula in order to update that m and c is, you see the new m is equal to m minus alpha into del L by del M. What is del L by del M? So this is nothing but a derivative of loss function with respect to m parameter. Similarly, in order to update the c value, the formula goes like this: c minus alpha into del L by del C, which is nothing but derivative of L with respect to c. And what is alpha? So alpha is known as learning rate in this entire equation. And the way we find it out, the derivative is given by this formula. Again, as an applied AI engineer, we don't have to remember this formula at all. That is not required. I'm just explaining you so that you will be able to understand how the m and c values are updated inside this algorithm. Okay, so this entire updation of the m and c happens with the help of algorithm which is called as back propagation algorithm, and before that we do the forward pass, which is nothing but prediction. So for example, let's suppose for one m and c value we got the equation as y equals to 0, right? After that we will be able to find it out the loss, then we'll do the back propagation. We try to update m and c. Now I'm gonna animate this entire thing, and you will see this entire thing will keep running into the loop till the time we will reach to the optimum value of m and c. So let me just click on animate, and you see over here, you see we are trying to reach out to this point where we have the m value as 10 and c value as 0, and this point is reaching to here. And on the right hand side, if you see, it is taking number of iterations. You see it has taken total 200 iteration. Okay, let me restart it once again. So let me click on animate, and you see here the number of iterations are going above. And you see, as soon as we are reaching to this particular best fit value, which is best fit line M and C, the loss is also decreasing. You see, you will be able to reduce the loss, and once you reach to this point, you will have a very perfect best fit line, and that equation will look like y equal to 10 into x plus 0. That is our best fit line in this particular example. Now coming back to the previous one, so you see, once if I change the value, let's suppose m as 10, okay, and c value is 0, you see my prediction line and the best fit line, which was actual prediction, now they are overlapping. And once we will be able to achieve this line, of course our model will be able to do the prediction. Now this is how a simple linear regression algorithm works, and that is how we will be able to predict for any given input x, which is hours of studies, what is going to be the marks for that particular student in that test. So this is how a simple linear regression works. Imagine you have only one variable over here, that is number of hour of studies, and you wanted to predict the marks. So that's why we taken a simple linear regression, which is going to be a y equal to mx plus c equation. But imagine now you want to predict the price of the house. So in that case, your parameters can be so much. For example, total area of house, location, number of bedrooms, number of bathrooms, number of balcony, and other parameters. And in order to capture all of these parameters, your equation might look something like this: y equal to m1 x1 plus m2 x2 plus m3 x3 dot 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 plus c, where you see this m1, m2, m3 and c, all of these are parameters for this particular equation. And what are these x1, x2 and x3? So these are nothing but our inputs, which is total area, location, number of bedrooms, and so on and so forth, right? So this is how basically you can consider the number of parameters we will require in order to only predict the house of the price. Similarly, when it comes to LLMs, so imagine a English language where we have lot of nuances to capture, like its language, its grammar, its vocabulary, and you can consider like different patterns which is available in the English language, or say like it can be any language. So in order to capture all of those patterns in the data, we will require a billions of such parameters. And that's why, if you remember, at the very start I have written this equation of the large language models. So we can represent the large language model in this format. Large language model is nothing but y next equals to function of x1, x2, x3 dot 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 action. And what are these x1, x2, x3? These are nothing but billions of parameters, which is essential in order to capture the different patterns available in the language. And that's why we can represent large language models with the help of this equation. Alright, so now we are in a position to describe LLMs theoretically as well as mathematically. In the next section, we will be covering the different nuances to prepare the data on which LLM gets trained. So see you in the next one.